USPS 955 Question Type 3 is Spatial Awareness. This section is testing your ability to visualize, rotate, compare, fold, and match shapes. It is not really about math. It is not really about memorizing definitions. It is about seeing how a shape changes when the view changes. You may see a cube turn to a different angle. You may see a flat pattern that folds into a 3D object. You may see top, front, and side views. You may see mirror images. You may see hidden faces. You may see a pattern where one missing piece completes the sequence. The key is to understand that spatial questions are shape logic questions. They reward careful visual tracking. You have to ask, what part stayed the same? What part moved? What face is now on top? What edge is still connected? What side became hidden? What option is impossible? A lot of people miss spatial awareness questions because they try to solve everything at once. They stare at the image and hope the answer jumps out. That is not the best method. The better method is to use a process. Pick a reference point, track one face, edge, corner, symbol, or direction. Then compare the options. If an option breaks the rule, eliminate it. Spatial awareness is not magic. It is visualization plus elimination. You rotate it, you flip it, you fold it, you view it, you compare it. The goal is simple. See it, turn it, solve it. The fastest way to read a spatial question is to find a reference point first. A reference point is something you can track. It could be a marked face, a shaded side, a corner, an arrow, a symbol, a unique shape, a notch, a hole, a colored face. Once you choose the reference point, keep it in your mind. That reference point becomes your anchor. Then track the faces, edges, and corners around it. Ask, what is above it? What is beside it? What touches it? What is opposite it? What moves when the object rotates? Then follow the rotation or fold direction. Do not jump straight to the final answer. Move step by step. If the object turns 90 degrees, imagine 1/4 turn. If it turns 180 degrees, imagine 2/4 turns. If it folds, ask which faces become adjacent and which become opposite. Then eliminate impossible options. This is where speed comes from. If an option places a face on the wrong side, eliminate it. If an option puts two opposite faces touching, eliminate it. If an option shows a mirror image when the question asks for rotation, eliminate it. If an option loses a unique feature, eliminate it. The slide example shows a cube being rotated. The correct answer is the one that keeps the reference point and face relationships consistent. That is the whole idea. Reference point first, rotation second, elimination always. That process is stronger than guessing. Mental rotation questions ask you to imagine the same object turned in space. The most important rule is this: rotation changes orientation, not identity. The object is still the same object, only the view changes. That means the faces move around, but the relationships between the faces stay consistent. If two faces are opposite, they remain opposite. If two faces touch along an edge, they still touch after rotation. If one symbol is on the top face, it may move to the side face after rotation, but it does not randomly jump to an impossible location. This is where many wrong answers are eliminated. A wrong answer may look similar, but it may break the relationship between faces. Maybe it shows two opposite faces touching. Maybe it reverses the face order. Maybe it creates a mirror image instead of a rotation. Maybe it moves a symbol to a place it could not reach by turning the object. When solving a mental rotation question, do not try to rotate the whole object all at once. Pick one feature. Follow that feature. For example, where does the colored face move? Where does the arrow point after the turn? Which face becomes visible? Which face becomes hidden? Think of the cube as a real object in your hand. Turn it slowly, quarter turn by quarter turn. Rotation does not change the object. It only changes your view of the object. That is the mental rotation shortcut. Folded and unfolded shape questions are about turning a flat net into a 3D object. A net is a flat pattern that can fold into a cube or solid. The key is to understand face relationships. Some faces become adjacent, some faces become opposite. Adjacent faces touch after folding. Opposite faces do not touch. That is one of the most important rules. If a choice shows two opposite faces touching, that choice is wrong. The best way to solve a cube net question is to find the center face first. Then ask, which face folds up above it? Which face folds down below it? Which face folds to the left? Which face folds to the right? Which face becomes the face opposite the center? Symbols and shaded faces are useful because they give you something to track. If the star is in the center, the faces around it become its neighbors. If the circle is above the star in the net, it may become the top face after folding. If the square is across the net from another symbol, they may become opposite faces. The question usually asks which folded cube matches the net. Do not choose just because the visible symbols look familiar. Check whether the relationships are possible. Can those faces touch? Are they in the right order around the corner? Is one face incorrectly placed opposite another? The shortcut is follow adjacency. Check opposite faces. Track the symbols. A correct folded shape must respect the net. Mirror image questions are different from rotation questions. A reflection flips the image. A rotation turns the image. That difference matters. A vertical mirror reverses left and right. If something is on the left side of the original, it appears on the right side in the mirror image. If an arrow points right, the mirror version points left. If a letter or symbol is asymmetrical, it may appear reversed. A horizontal mirror reverses top and bottom. Something above the mirror line appears below it. Something below appears above it. The important rule is this: a reflection does not rotate the object unless the question shows a rotation. It flips position across the mirror line. That means the object's orientation changes in a specific way. Many wrong answers are actually rotated versions, not mirror images. So when you see a mirror question, ask, where is the mirror line? Is it vertical? Is it horizontal? Does the answer flip the correct direction? Did the option rotate instead of reflect? For multiple choice questions, look for reversed letters, arrows, numbers, or asymmetrical shapes. Those details reveal the answer quickly. If both left, right, and top, bottom are reversed when only one should be reversed, the answer is probably wrong. The takeaway is simple: reflection flips position. Rotation turns direction. Do not confuse the two. Top, front, and side view questions test whether you can connect a 3D object to its 2D views. The top view is what you see when looking down from above. It shows the footprint. It shows width and depth. It may not show height unless height is represented in another way. The front view is what you see when looking straight at the object from the front. It shows width and height. The side view is what you see from the left or right side. It shows depth and height. A common mistake is mixing up width, depth, and height. For example, a stack of cubes may look tall from the front, but from the top it may only look like a flat arrangement of squares. Hidden blocks can also change the view. A block behind another block may not be visible from the front, but it may appear in the top view. When solving these questions, imagine where you are standing. If the question asks for the right side view, mentally stand on the right side of the object. Look straight across. Count how many cubes are visible at each height. If the question asks for the top view, imagine looking straight down. Count the footprint. If the question asks for the front view, look straight at the front face. The rule is, one object can create 3 valid 2D views. So match the correct view to the correct direction. Do not rotate the answer randomly. Viewpoint decides what you see. Hidden face questions test whether you can imagine parts of a solid that are not visible. Not every cube face can be seen from the outside. When two cubes touch each other, the touching faces are hidden. They are interior contact surfaces. That means you cannot count every face of every cube as visible. You have to count only exposed faces. The best method is to build the solid mentally. First, identify the cubes you can see. Then ask what cubes must be behind, underneath, or supporting the visible cubes. A tall stack usually requires support underneath. A cube that appears floating may actually need hidden cubes below it. A cube behind another cube may be blocked from view. Then count visible faces by direction. Top faces, front faces, right side faces, left side faces, back faces, if visible, bottom faces, if the question includes them. For exposed face questions, each cube can have up to 6 faces, but touching faces are not exposed. So if 2 cubes touch, that shared contact hides 1 face from each cube. That is why the visible face count is often less than people guess. For solid assembly questions, the idea is similar. Which assembled shape can be made from the parts? Look for how the blocks must connect. Check whether the final shape uses all parts. Check whether any cube is unsupported or misplaced. Build the solid mentally first. Then count what can actually be seen. Pattern matching and shape completion questions are about finding the rule. The answer is not always the option that looks most familiar. It is the option that follows the same pattern. Look for position, look for size, look for rotation, look for shading, look for direction, look for repeated movement, look for the missing piece. In a pattern completion question, ask, what changes from the first image to the second? What changes from the second to the third? Is a shape moving clockwise? Is a symbol alternating? Is shading rotating? Is the same object flipping? Is one part being added or removed? For shape completion, look at the missing edge. Which answer piece completes the outline? Which piece matches the angles? Which piece continues the line? Which piece has the correct notch, corner, curve, or side length? Do not choose only by general appearance. A piece may look close but fail at one edge. That makes it wrong. For arrow or symbol patterns, track direction carefully. If the arrow turns 90 degrees each step, the next arrow should continue the turn. If the sequence alternates between shape positions, the missing option must continue that rule. The key phrase is, look for rule consistency, not surface similarity. A correct answer follows the rule. A tempting answer only looks similar. Spatial awareness questions become faster when you stop trying to prove every answer correct. Sometimes the fastest path is to eliminate what cannot be true. First, eliminate wrong face order. If the faces appear in the wrong sequence around a cube or corner, the option is wrong. Second, eliminate impossible mirrors. If the question asks for a rotation but the option is a left-right reversal, eliminate it. If the question asks for a mirror image but the option is just rotated, eliminate it. Third, eliminate broken adjacency. If two faces or features touch in the original but are separated in the option, the answer may be wrong. If two opposite faces are shown touching, eliminate it. Fourth, eliminate mismatched views. If the top view, front view, or side view does not match the option's height, width, or depth, eliminate it. Fifth, eliminate wrong visible edge counts. If the target shape has 9 visible edges and an option has 7 or 11, it may not match. The powerful idea is this. You do not always have to solve everything. Sometimes you only need to prove that 3 answers are impossible. The remaining answer wins. That is how test speed improves. Pick one detail, track it, cross out anything that breaks it, then use another detail if needed. Spatial questions reward careful elimination. Perfect visualization is not always required. Eliminate the impossible, then choose the best remaining match. This is the first cheat sheet for spatial awareness. Rotation means mentally turning the shape in space. The object stays the same. Only the view changes. Use small steps. 90 degrees at a time is easier than trying to jump straight to the final answer. Folding means imagining a flat pattern becoming a 3D shape. Follow fold lines. Track adjacent faces. Remember that opposite faces never touch. Mirror means flipping across a mirror line. A vertical mirror reverses left and right. A horizontal mirror reverses top and bottom. Reflection is not the same as rotation. Views means matching top, front, and side perspectives. Picture where you are standing. Then count heights, widths, depths, and visible blocks. Hidden faces mean using what you know to find what cannot be seen. Cubes that touch hide their contact faces. Cubes underneath may be required for support. Elimination means crossing out what cannot be true. Wrong rotation, wrong mirror, wrong face order, wrong visible edges, wrong adjacency. The final rule is the strongest. Fix the reference point. Track the change. Eliminate the impossible. That is how spatial questions become manageable. Slide 11 focuses on direction changes in angle tracking. This is important because many spatial questions ask what direction an arrow, object, or feature faces after it turns. The mistake is trying to jump straight to the final direction. Instead, use quarter turns. A 90-degree turn is 1/4 turn. A 180-degree turn is 2/4 turns. A 270-degree turn is 3/4 turns. Clockwise turns move in the direction of a clock. From up to right, right to down, down to left, left to up. Counterclockwise turns move the opposite way. From up to left, left to down, down to right, right to up. If an arrow starts facing north and turns 90 degrees clockwise, it points east. If it then turns 180 degrees clockwise, it points west. If it then turns 90 degrees clockwise again, it points north. That is why step-by-step tracking matters. Do not try to feel the answer. Track it, Use north, east, south, and west if that helps. Use arrows if that helps. Use your finger if you are practicing on paper. The key is to update the direction after each turn. One feature, one turn at a time. That is how you avoid guessing. Track one feature, turn step by step, then choose the answer that matches the final direction. Counting cube questions often trick people because not every cube is visible. You may see the front cubes. You may see the top cubes. But you may not see the cubes behind or underneath. That is why the rule is total cubes equals visible cubes plus required hidden support cubes. Start by breaking the figure into layers. Think bottom layer, middle layer, top layer. Count the visible cubes in each layer. Then ask what must be hidden to support the visible structure. If a cube is stacked high, something usually has to be underneath it. If the drawing shows depth, there may be cubes behind the front row. If a column rises from the back, some of the lower cubes may be partly hidden. The slide example shows the idea. You first count what you can see. Then you add the hidden support cubes that must exist behind or underneath. Then you add layer by layer. This prevents undercounting. A common wrong answer counts only the visible cubes. Another wrong answer counts too many cubes because it assumes every space is filled. The better method is careful layer logic. What must be there? What can be seen? What is hidden? What is required for support? For USPS 955 spatial awareness, this is a very useful skill. Think in layers, check depth, ask what must be behind or underneath. Then add the cubes carefully. Cube net questions are about face relationships. A cube net is a flat pattern that folds along edges to form a cube. The key is figuring out which faces become adjacent and which faces become opposite. Start with the center face if there is one. The faces directly attached to the center face usually fold up around it. Those attached faces become neighbors of the center face. The face that is farther across the net may become opposite the center face or opposite another face depending on the net layout. One strong shortcut is to identify faces across the center. Faces that fold around the cube may become opposite after folding. The slide example asks, which face is opposite the star? To solve it, do not just look at the flat layout. Mentally fold the faces upward. Ask, what touches the star? What does not touch the star? What lands across from the star after the cube closes? That is the face opposite the star. A wrong answer may choose a face that is adjacent to the star. But adjacent is not opposite. This is the key difference. Adjacent faces share an edge. Opposite faces do not touch. So the solving method is, find the center face. Fold around it, identify touching faces, then identify the face across from the target. Cube nets become easier when you stop guessing and start tracking relationships. 2D to 3D matching asks you to connect a flat drawing with a solid object. Sometimes you are given a 2D net and asked which 3D object it forms. Other times you are given a 3D object and asked which flat pattern could build it. The main skill is connection logic. Which edges must connect? Which faces must touch? Which faces must wrap around the same corner? Which features must stay together? Do not only compare the general shape. A wrong answer can look close but have one face in the wrong place. Start by matching unique features. A missing corner, a long side, an extra block, a shaded face, a symbol, a notch. Those details are easier to track than plain square faces. Then check the order of faces around a corner. If the flat net says blue, green, and yellow meet around one corner, the 3D object must show those faces in a possible order. If the option would require two faces to overlap, it is wrong. If the fold leaves a gap where a face should be, it is wrong. If the same face would have to appear in two places, it is wrong. The correct answer is not just the one that looks similar. It is the one that respects every connection. Match the edges. Check the face order. Use unique features to eliminate fast. Only one option should fit all connections. Shape fit questions ask whether a piece can fit through an opening. This is not just a size question. It is an outline matching question. You need to compare the full shape. Look at protrusions. These are the parts that stick out. Look at missing corners. Look at indentations. Look at unique angles. Look at side lengths. Then mentally rotate the candidate piece to see if it can match the opening. But do not flip it unless the question allows flipping. That is a major trap. A piece may fit only if mirrored, but if the task allows rotation only, that option is wrong. Rotation turns the piece. Flipping creates a mirror image. Those are not the same. Also, do not resize the piece. Assume the proportions matter. If a side is too long, too short, or not in the correct location, eliminate it. In the slide example, the correct piece is the one whose outline matches the whole after rotation. The piece has to match the edges, corners, notches, and orientation. A tempting answer may have the same general shape but place the indentation on the wrong side. That is not a match. The method is: count protrusions, count missing corners, match unique angles, mentally rotate, do not flip, do not resize, match the whole outline. That is how you solve shape-fit questions. Slide 16 separates mirror, flip, and rotation. This is one of the most common spatial awareness traps. A mirror image is a left-right reversal. It changes handedness. The shape looks like it was reflected in a mirror. A rotation is the same shape turned in space. The top may move to the side. The arrow may point a new direction. But the shape's handedness stays the same. A flip can depend on how the question is worded, but in many test situations it behaves like a reflection across an axis. So the first question is, does the question allow mirror images? Or only rotations? If the question asks which option is the same object rotated, do not pick the mirror image. If the question asks for the mirror image, do not pick a rotation. One easy way to test this is to look for an asymmetrical feature. A tab, a notch, an arrow point, a missing corner, a letter. If the tab switches sides, it may be a mirror. If the tab moves around the shape but keeps the same relationship, it may be a rotation. The slide example shows that the mirror option reverses the shape left to right. The rotated options are the same shape turned. The tip is simple. A mirror changes handedness. Rotation does not. If you can spot that difference, you can eliminate a lot of wrong answers quickly. Fast elimination is one of the best ways to improve spatial awareness scores. You do not always need to visualize everything perfectly. Sometimes you only need to find what makes an option impossible. Step 1. Find the unique feature. Look for the feature that stands out. A colored face, a notch, a symbol, a long side, a missing corner, a raised block, a rotated arrow. Step 2. Eliminate impossible options. If the option is missing that feature, cross it out. If the feature is on the wrong side, cross it out. If the faces are not adjacent when they should be, cross it out. If the shape is mirrored when it should be rotated, cross it out. Step 3. Check orientation. Make sure top, left, right, front, and back relationships still make sense. A cube may look correct, but the left and right faces may be swapped. A shape may look similar, but the top face may be wrong. Step 4. Confirm the final match. Only one option should match all the important details. The slide example shows this logic clearly. Some options have the wrong top. Some have the wrong right face. Some have left and right swapped. Only one option keeps all the features in the right relationship. That is why elimination is speed. Perfect visualization is not always required. You only need enough tracking to prove which answers cannot be true. Slide 18 is a practice question. The question says, a shape is built using identical cubes. Which view is the right side view of the shape shown? The key phrase is right side view. That tells you where to mentally stand. Imagine you are standing on the right side of the shape, looking straight at it. Do not look from the front. Do not look from the top. Do not rotate the answer choices randomly. Stand on the right side. Now count what you would see. How many cubes are visible across the bottom? How tall is the stack? Where is the tallest column? What profile does the shape create from that side? The correct answer shown is BY. From the right side, you would see a row of 3 cubes across the bottom and a 2-cube high section on the right. That matches option B. The other options may look close, but they do not match the right side profile. This is the entire skill. For view questions, physically imagine where you are standing. Front means straight ahead from the front. Top means looking down. Right side means standing to the right and looking straight across. Then match the outline. Do not overcomplicate it. Find the viewpoint. Count the cubes at each height. Match the profile. Practice builds spatial confidence. Slide 19 is a paper folding question. The question says a square sheet of paper is folded twice. First, it is folded in half horizontally. Then, it is folded in half vertically. A hole is punched in the folded corner. The question asks what pattern appears when the paper is unfolded. The key is to reverse the folds. When paper is folded, layers overlap. A hole punched through the folded stack affects every layer underneath that punch. So when the paper unfolds, that one punch appears in multiple mirrored locations. First, think about the second fold. When you unfold that vertical fold, the hole reflects across the vertical center line. Then think about the first fold. When you unfold the horizontal fold, the holes reflect across the horizontal center line. Because the paper was folded twice, the hole pattern appears across both axes. The slide shows the correct answer as D. That answer reflects the hole positions around the edges according to the fold sequence. This is why fold questions require step-by-step thinking. Do not only look at the final picture. Track the hole. Unfold one step, then unfold the next step. Each unfolding creates a mirrored copy. The more folds, the more copies appear. The rule is, visualize the folds. Track the hole. Unfold step by step. Trust the process, not the guess. This is the final cheat sheet for USPS 955 Spatial Awareness. First, rotate. Mentally turn the shape in your mind. Use small steps. 90 degrees at a time is easier than trying to jump to the final view. Second, view. Picture the shape from the top, front, and side. Stand in the viewpoint the question asks for. Then match the profile. Third, mirror. A mirror flips the shape. Look for reversed details, reversed arrows, reversed letters, or swapped left and right. Remember, mirror and rotation are not the same. Fourth, fold. Imagine the shape folding along the given lines. Track which faces touch. Remember that opposite faces never touch. For paper folding questions, unfold step by step and mirror the holes or marks across each fold line. Fifth, eliminate. Cross out what cannot be true. Wrong face order, wrong viewpoint, wrong rotation, wrong mirror, wrong number of visible cubes, wrong adjacency. Finally, practice. Spatial awareness improves with repetition. The more you practice rotating, folding, viewing, and eliminating, the faster your brain recognizes the patterns. You do not need to panic. You need a process. Fix the reference point, track the change, eliminate the impossible, think in 3D, stay calm, use process, not panic. That is how you improve question type 3.